What is light? The answer may seem obvious. Light is where it isn't dark. Or perhaps you're a poet or philosopher, writing about light as a metaphor for truth, courage, or kindness.
But I'm a physicist. That isn't enough for me.
As it turns out, the nature of light is a question physicists much smarter than me have been wrestling with for quite some time.
During the 17th century, the highly respected scientist Isaac Newton believed that light consisted of particles. Though even he saw some inconsistencies in his theory, it was still the most reasonable at the time, and most members of the scientific community agreed with him. The first person to challenge Newton on the nature of light was Thomas Young. He believed light may be a wave, like sound. Young knew that two sound waves could interfere with each other. Interference happens when the peaks of one sound wave line up with the troughs of another, canceling out the sound. However, when the peaks of both waves align, the total sound gets louder. Young reasoned that if he could find similar interference patterns in light, that would mean that it too was a wave. He designed an ingenious experiment to test his theory.
I'm going to build a more modern version of Young's experiment called the double slit experiment. In it, a laser hits a surface with two tiny parallel slits. The light from each of the slits emanates towards a screen. If light does indeed show wave-like properties, the light from each slit will interfere with the light from the other, creating a pattern of bright and dark spots on the screen. Here is the finished experiment, including the laser, slits, and screen. Let's turn it on. The wavelength, lambda, is equal to the distance from the center of the screen to one of the bright spots, times the distance between the slits, all divided by the distance between the slits and the screen. So, if the first bright spot is 1 centimeter away from the center, and the distance between the slits is 0.6 millimeters, and the distance to the screen is 10 meters, then our laser has a wavelength of 600 nanometers.
Light is one of the most fascinating topics in physics, and it is infinitely more complex than what can fit into this short video. For example, quantum physics tells us that light is both a particle and a wave. In that respect, both Newton and Young were correct, but it was Young's experiment that provided the necessary evidence that light was something worth learning more about.